Hey there, in this video, I'll share with you two effective approaches to determine the limiting reactant and how much of the reactant that was in excess at the end of the reaction. I'm Orlando Broomfield from Chemistry Core. Let's solve this chemistry exam style question together. Let's use two approaches to set out the solution to our problem. In the first approach, we will keep the quantities given in the question mass to relate the masses of the reactants to the mass of the carbon dioxide product formed. And in the second approach, we will convert those masses given in the question to moles to relate the number of moles of the reactants to the number of moles of the steam product formed. The product chosen for each approach does not matter, so it is totally our choice. The point is that ultimately, whatever product we decide to use, we should end up with the same conclusion. Starting with the first approach, we need to find out the theoretical amount of masses of the reactants and the carbon dioxide product and relate that to the given masses used in the question to determine which of the two reactants, whether it is propane or oxygen, that limits the maximum amount of carbon dioxide product formed in the reaction. That reactant will be our limiting reactant. The other reactant will be in excess, which means that after the reaction has ended, some of that reactant remains. Let's begin, however, with the balanced chemical equation. For the coefficients in the balanced chemical equation gives us the number of moles of the molecules involved. So the mass of 1 mole of propane is, the mass of carbon is 12 based on the periodic table, and that of hydrogen is 1. So 3 times 12 plus 8 times 1 gives us 44 grams per mole. The mass of 5 moles of oxygen molecules is, the mass of oxygen is 16, so 10 times 16 gives us 160 grams per mole. And the mass of carbon dioxide, and there are 3 moles, is 3 times 12 plus 6 times 16 gives us 132 grams. So let's relate the mass of propane to the mass of carbon dioxide formed. Theoretically, 44 grams of propane make 132 grams of carbon dioxide. So if we start with, based on the question, 25 grams of propane, we will make X grams of carbon dioxide. By the method of cross multiplication, X times 44 is equivalent to 132 times 25. X is therefore equivalent to 132 times 25 divided by 44. That gives us a total of 75 grams of carbon dioxide made. Let's now relate the mass of oxygen to the mass of carbon dioxide formed. Theoretically, 160 grams of oxygen will make 132 grams of carbon dioxide. Therefore, if we start out with 80 grams as stipulated by the question, divided by 160, X is equivalent to 66 grams of carbon dioxide. Since we make a lesser amount of carbon dioxide starting with 80 grams of oxygen than we make starting with 25 grams of propane, then oxygen is the limiting reactant. It will be completely used up first in the reaction, and the propane is in excess, so we need to determine how much of the propane was used and therefore how much remains after the completion of the reaction. So we are going to work backwards from the amount of carbon dioxide made from the limiting reactant. Theoretically, 132 grams of carbon dioxide require 44 grams of propane. So 66 grams of carbon dioxide will require X. X is equivalent to 44 times 66 divided by 132, 22 grams of propane used. So, how much remain after the reaction has been completed? We need to subtract this amount from the starting amount. So, excess 25 minus 22, 3 grams of propane. Now for our second approach. In this second approach, we need to relate the number of moles of the reactants to the number of moles of the steam product formed. Let's convert the number of grams of the propane and the oxygen used to moles. To do so, we need to convert the grams to moles by dividing by the molar mass of each of the molecules. So starting with propane, we have 25 divided by 44, which is 0.568 moles of propane. And for oxygen, we have 80 divided by 32, the molar mass of one molecule of oxygen, and that gives us a total of 0.5 moles of oxygen molecules. Let's now relate the number of moles based on the given amount in the balanced chemical equation for propane to steam. So 1 mole propane will make 4 moles of steam. So 0.568 moles of propane makes X moles of steam, and X can be determined by multiplying 4 times 0.568, of course divided by 1, which is 2.72 moles of steam. Let's now relate the moles of oxygen to the moles of steam. So, theoretically, based on the balanced chemical equation, 5 moles of oxygen will make 4 moles of steam. Therefore, 2.5 moles of oxygen will make X moles of steam. X is 4 times 2.5 divided by 5, and that gives us 2 moles of steam. So here we see again that the limiting reactant is the oxygen, as it limits the amount of steam product that can be made. So working backwards, we will be able to determine the amount of propane that were used in the reaction. So if 4 moles of steam require 1 mole of propane, then 2 moles of steam require X. Now 4 is half of 2, so X of course is half of 1. So X is equal to 0.5 moles of propane. Now 0.5 moles of propane is half of 1 mole of propane, and that mass is half of 44, which is 22 grams. So we can write, therefore, 0.5 moles of propane is equivalent to 44 divided by 2, which is 22 grams of propane used in the reaction, just as we got in the first approach. So in terms of excess, we need to subtract 22 grams used from the 25 grams that we started with, and that works out to be 3 grams of propane. Thank you for watching another video on solving problems in chemistry with Chemistry Core. If you were tuned in, you are now able to relate the amount of reactants at the beginning of a reaction to the amount of products formed to determine which reactant was completely used up first, thereby limiting the maximum amount of product formed, and how much of the reactant in excess remains at the end of the reaction. Good luck on your exams, and I'll see you next time.